Hello, folks. It's been some time since we last met each other, but I guess today is the day when we get to do some interesting problems. So, one of the channel subscribers suggested that we should do this problem, remove all adjacent duplicates in a string. And he suggested that we should do using stacks. So I said, why not? Let's follow that approach. So we're gonna do this problem using stacks, and let's see if we can nail it. So it says, given a string S of lowercase letters, a duplicate removal consists of choosing two adjacent and equal letters and removing them. We repeatedly make duplicate removals on S until we no longer can. Return the final string after all such duplicate removals have been made. It is guaranteed the answer is unique. So the example he gives you is A, B, B, A, C, A. And as you can see, when you remove BB, you will end up with AA, which can be removed again, and you'll be left with CA. So that's where we have our um, solution. And then some of the constraints in the problems are that you need to have the string length will be less than or equal to 20,000 characters, and the string will only consist of English lowercase letters. So there you have it. Let's give it a shot and let's see what we can do. So first of all, anytime you have an array, you can be guaranteed to that you would need an indexing variable, because you will be walking the array, right? So let's have that as an I. This is the convention, and then we will have another variable which hopefully I think we're going to be popping characters from the string, so we probably need one for that. So what we will do is we'll use a top-down approach here. It's like we know this is what we need to do. We assume that we have some prototypes for stack manipulation. So let's take some of these prototypes. So one I can see is that suppose you want to initialize the stack. So that would be, I would say, let's just call it stack init, and that would be, let's say, just take a pointer to a stack, right? How about this? So that's one prototype. Other prototype, let's say we have a prototype known as a stack top, which gives you the current element at the top of the stack. So that's your stack top, by the way, doesn't take any other argument either. And now you have a stack push. Actually, you know what? A stack push and a stack top. Okay, stack push. They both actually will return a integer. So that would be your stack star s. And then int d. So the idea is that we may probably write some comments here if you want. We can say returns the current top of the stack or else -1. So that's kind of, it helps us to know that when the stack is empty. And same thing here, that if we cannot push, then we have to probably return an error or something like that. Or maybe we don't even need to do that. We can um, simply return a void here for the time being, I guess. All right, so let's start doing it. So basically, you start walking. You say I equal to 0, I less than strlen s minus 1, and then you say I plus plus, and then what we do is we say that if your current stack, so say stack top, and then you pass the, we'll call that as my stack or whatever the heck you want to call it, but here if stack top, okay, so stack top, as you know, actually returns the current of the stack. So we have to say c equal to, let's just call, assign the variable c to this value is equal to si. Okay, then what do we need to do? We can simply do a stack pop, right? Right. So else what we would do, we will say stack, else we would just simply, so if it is if you see that the current element that you're dealing with in the string is what is this, the same element that you have at the top of the stack, we can pop, otherwise we have to push, right? So what is the pushing means? We just say my stack and then si, right? There you go. So that's pretty much your implementation of pushing and popping. Otherwise we initialize I to 0. So now at the end of it, we know whatever we have left in our stack is actually is what we need to return with few caveats. And so then now what we can do is we can say for, okay, so now I equal to 0, I less than, oh no, not I actually, I don't think this for loop is going to work here. Let's do a while loop. So while stack top, so stack, okay, instead of in this case doing an si, we're going to do a minus, we'll actually check what we get with -1 is not equal to -1, right? As long as there are elements on the stack, basically, that's all it means. We can continue to, what we're going to do is we will do a, again, I guess we can, I guess it's good to have c equal to here in this case also. While, so that is your, this is, I think looks good. Okay, so and then if that is, if c, then we can just simply say we are going to use the same string that we are passed in, rather than actually doing a dynamic memory allocation for the return character. So we can do this plus plus, so that next time around we have the right index, and then we can do a pop, because we have to actually get rid of that, right? So there we actually got rid of it, and then we come here. At this point, everything is looking good in our SI, but one caveat, which is that you have a string kind of formed in a reversed manner. So we need to reverse the string, because you see, think about it. You would have, in the end, you would have had left on the stack as C and A. But when you pop, you'll get A and C. So you need to have it reversed, and that is easy to do. We have been doing it for a while. So that's your I. But before that, I guess there's one more thing we can do. This, it doesn't hurt. We can we can null terminate our string. Very, very important stuff for C. For C programmers to know that in C, strings are null terminated. Never ever forget it. So, and after this point, all we need to do is return as. Now this should work if we can implement all these helper functions. So how are we going to implement these helper functions? So one thing you got to do is, let's do the stack init. Before that, let's define what the stack looks like. So you can say type def, type def struct stack, and then we can have a array. So we're going to call it int whatever you want to call it. Basically I'm going to call it int a, maybe that's fine, any kind of, that doesn't matter what you're going to call it. It's basically um, stack size, let's call it a stack size, and then size actually. So basically your stack is nothing but an array implementation which should suffice for the purpose of interviews, because I don't think it's going to be more complicated. You don't have much time during the interview. So you have an array, okay, and then the stack size, and what should be the stack size? Let's just do that. And as you can see, it's saying your string has to be at least 20,000. So there you go. So stack size, and so that is your, okay. So now type depth. So that means we need to have an, okay, there you go. So that's your stack, folks. And now let's try to implement these functions. So stack init, for example, is easy. It's kind of, I would say, trivial, and that is that this is extremely trivial, and all we need to do is we say as size equal to 0, right? And then stack top. Okay, so what do we need to do here? Let's see. So if as size is equal to 0, we know we have a problem. We can probably do a printf error message if you want. If you want to do, we can do that. It will do something like this, and you can say stack empty, sorry. And then we can also do a return -1. Else we are in good shape. We can simply return as error, and then we know where we are. So remember, we will be putting in at the index size, and then we will be returning from size -1, right? So that's your pretty much stack top function. Now stack pop, and that's coming back to, did we even have pop? So you see, I have init, I have top, I have pop. Okay, so this, which I actually forgot to have that function prototype here. So which is, now when you say pop, only thing pop does is it basically gets rid of the element at the top of the stack. Remember, so there's no we don't have to pass anything else. We can simply say, okay, here, how about this? So now we have this. So let's implement a stack pop. Alright, what am I doing here? Okay, stack pop again takes a pointer here, and then what does it do? All it does is it basically gets rid of, okay, now stack pop, remember again, if your stack is empty, you're not going to be able to pop. So it's pretty much the same function, I would say, but only thing we need to do is that we just have to reduce the, rather than returning anything, I think, see here there's a problem here, we have to do a return statement here. Okay, so here as size minus minus, right? The only thing we did is we actually reduced the we just basically gotten kind of forgot that value in the stack. Now stack push. So stack push would be easy to, which is basically, so that is our stack push. It returns nothing, but what it does is this: if s size is less than stack max, that means we can go, in our case, like for example, if you have 100, then we can go up to 0 to 99. But if the current index is saying 100, we have a problem. That means we cannot push anymore. So we can say, if you want, we can put an error message saying, hey, stack full. Else we are in good shape. All we need to do is we need to put stuff at the index size. So that's your D. Now one thing you might notice is that even though we are going to be working on a string which is built from characters, we are actually using integers here, and that's not a big problem because, as you know, in a char in C is nothing but a 1 byte integer. Remember that part. So it should be okay. So we don't have to worry about that. And also he's saying that your see, he's saying S consists only of English lowercase letters. So make use of that fact. Alright, so everything is looking good. Only thing now we need to have is a reverse function, which is trivial, and that is your int len. So that is char temp, and you can say int I equal to 0, j equal to pointing to the back of the string, and then keep going while they meet, until they meet each other. Looks like my typing today is extremely horrible. Okay, so j minus minus. Okay, so here we are, I less than j. Okay, so temp equal to si equal to sj, and sj equal to temp, right? And that's your string reverse function. All we need to do now is have an actual my stack variable, global variable. So that's your stack my stack. How is that? I think this should work. Let's give it a shot. Okay, so he's saying line 30. What is happening at line 30? Let's see. He said return with a value in function returning void. If s size less than stack max. Why is saying that? Oh, I see. So return with a value in function returning void. That shouldn't be happening, right? Why is that the case, that we have a return with value in a function returning void? So char 16 return with a value in function returning void. Return -1. I don't think I have return -1. Return. Oh, shoot. Stack pop. So remember, a stack pop was just supposed to not return anything, right? Because it's just so let's just comment out this line. I think that should take care of that. Okay, in line 19 we have a problem. Let's see. Stack max undeclared, stack size. That's easy to fix because we actually have wrongly used the macro here. It should be stack size. Easy. Okay. Now he's saying we have a problem here, which is he's saying error subset value is neither array nor okay char star s. There you go. That was easy. Now where we are the problem. Problem is line 69. Okay, we have redeclared I. No, we don't want to do that. There you go. So that should be a problem now, not be a problem. Okay, now he's saying we have a problem because that was easy to fix because we are using the wrong variable name. Again S, again capital S basically, but that was the name of the the function argument here. Okay, so here wrong answer. So why is that a wrong answer? He's saying you are returning nothing. You should have returned CA. Did we screw something up? So that's your S. Return S, reverse SI. I said SI equal to this. SI plus plus equal to C stack top. While C equal to stack top I0, I is equal to stack top, address of my stack not equal to -1. Okay, we said Si plus plus equal to C stack pop, and we got rid of that thing, and then we said Si equal to null terminate and reverse Si. Did we screw something up here? Si equal to Sj, I is 0, j equal to len -1. Should be alright, right? Stack push is if S size less than stack size, stack full, else S or S size. Oh shoot. Because you see, when you are pushing, you have to keep incrementing the size, the current index in the array. Because next time around, okay, let's try this time. We still have a wrong answer, sir. So that's, let's see what did we screw up. So S size plus plus, so S size we put into D. Now stack pop, all we did is we said S size minus, that was good. That's, I don't see a problem here. And stack top, we said return the value at S size -1. S return -1. S size equal to 0 and stack size is 20,000. Have we mashed something up? Okay, I know what is the problem. The problem is when you do a pop, you basically, you should be doing, oh, so that should be okay, man. S size here, S size plus plus equal to D. And so what did we screw up? Let's see. So output is still coming out to be, maybe we should do a printf of the string at this point. And this is a very good exercise in debugging. That's what programming is all about, right? We have to debug. So let's see what did we get here. So that will tell us if we had even done the job of pushing and popping in the first place, right? He's saying you were not able to get rid of anything. Look at this. Output, when I said here, S is, okay, S, oh, no. I was saying that, of course, S will remain what it is, but what is on the stack? So what we should be doing is we should be actually printing D here to see what are we getting. So that's your C, and this is Let's see what do we get here. Nothing. That's interesting. We did not even, I'm wondering if we are going in this while loop at all. While C equal to stack top address of my stack not equal to -1, printf s equal to %c. How come we didn't print anything at all? That is extremely disappointing for this morning on the day of the 6th of November. So S equal, so he print, we can see that we went here, but I'm surprised that we never printed any of these, even though we should have said one each character equal to %c. Why we don't have a problem %c? Because we have int c, that shouldn't have been a problem. Let's see d. Nothing was printed. That's not a problem. That's a problem also. Why? So did we even, while c equal to stack top, address of my stack is not equal to -1. What the heck is the problem? If you see a problem, you should probably print that in the comments, and maybe we should just leave it at this. I think it is a good brainstorming exercise at this point. S size 0 stack top returns the element at the current, okay, here it has says S size -1, so that was looking good as well. So then what is the problem? Stack pop is, if size is 0, we have a problem. Then we can say return, okay, then we don't actually, we just say S size minus, okay. And stack push is, and reverse is fine. So first of all, what we can do is we can probably try to print some of these things in each of them and say, hey, maybe here we should printf here. We can say returning, and that is your %d here because we are storing them as integers. And then here we can say pop, right? Pop is fine, but push, we can say pushing. Let us see if we get something over here. Pushing D actually, right? Okay, let's try now. Nothing happened. None of these got printed. I'm wondering, did we even, for I equal to 0, I less than strlen s -1. Oh shit. I think this should have been okay. Y -1. Still, I didn't see any of these printed. Okay, so remove duplicates was called or not? What was the function? Wasn't it remove duplicates only? Car star s. We see that standard output is saying s is equal to, this s was printed here, but I equal to 0, I less than strlen s, I plus plus. if C equal to stack top address of my stack, how come we did not see any of these things printed? See, we had a stack, we had a returning this thing here, this is statement. So I equal to 0, I less than str len s plus s. Okay, you know what? Let's do some of the submissions I had. I done a submission before I started doing one, and that was working. So we can take a look at that. So let's see. Stack push was y s size plus plus d, and s size equal to stack empty else s size minus minus. Oh shoot! We forgot to do a stack init here. You see that? And that has caused us grave harm, I would say. Otherwise, it was all right. So let's go here. So as you can see, we did have this variable, but one thing we forgot to do is this. I wonder, there shouldn't have been a problem if it is a global variable. If it is a global, shouldn't stack init kind of not be an issue? And we still have a wrong function. So let's do one thing. What we're going to do is we know that this implementation, I know I just did it before starting it on recording, it was working. So let's do this. Okay, so far as you can see, stack max, stack size, it doesn't matter whatever the heck you want to call it, data or air, whatever the heck you want to call it. S size 0, stack top here, f printf, right? Return -1, so stack top we have implemented. Let's do a stack push and stack pop. These look easy. We already did that. So that is your if s size 0, s size minus, right? So that is your void s size minus. You pretty much forget the element at the top of the stack. Now let's do this reverse, which is trivial like what we did. And now let's do the actual implementation. So I think it was the same as what we were doing, but for some reason I think we screwed something up while going through. Let's try this one. Okay, so as you can see, it is working fine. I'm wondering what had we screwed last time. This is pretty much the same that I was doing. I mean, in fact, I had already done it just before submitting, just before attempting it in real time. So here, C define stack max, stack is declared, stack init, stack top is done. Stack top is basically it returns the current element at the top of the stack, and the function signature is int. Basically, it returns an integer, takes the pointer to the stack. The stack push returns nothing, but takes the second argument, the integer to be pushed, or the character in our case. But we are using integers because characters are nothing but integer. The stack pop takes the pointer to the stack. Only thing it does is it basically forgets the, if you are more than s size, if s size is not 0, then it just basically reduces the s size. And reverse is trivial. So then remove duplicates, stack init, okay. If stack top equal to si, basically this is the crux of the problem here. See, if you know that your current character in the string is what you already have in the stack, then we have a duplicate and we can simply pop, otherwise we are keep pushing. Keep pushing, and popping, if you see that you have a duplicate, which is basically pretty much seen here at this line 60 and 61. And after that, all you're doing is walking, popping each character from the stack, but you know that that will give you a reverse string, so you're reversing. So there you have, guys. Let's do a submit, and that should basically fix this. There you go. It basically is 68 millisecond faster than 16% of C online submission. So today is our day of glory, I would say. We can walk like the Napoleon walked after he has won the battles in the Europe. So it's like we have conquered the world. That's the feeling you get when you have done a challenging problem. So this is your implementation of remove duplicates using stacks. I hope you had fun. And the biggest challenge, the programming is all about debugging, getting stuck, messing around, and as more you mess around, better you get. It's like wrestling with God, as some religions like to say. So here we are, and I hope you had fun. I'll see you in the next video. Adios, hasta mañana.